So let's talk about what happens if the problem starts off as a logarithmic equation instead of an exponential equation. So you have something like log base 5 of x equals log base 5 of 7. Well, in this particular case, you can see that since they're both log base 5 and this is equal, then these have to be equal to each other. So we'll start working log equations that look like that. So something like log base 3 of 5x minus 1 equals log base 3 of x plus 7. So since these are equal to start with, and they both have log base 3, then these have to be the same. So 4x equals 8 and x equals 2. Now, if you'll remember, whenever we were solving problems that dealt with square roots, we might find sometimes that when we took both sides to a power, we would create solutions that weren't real solutions. So anytime our problem starts as a log, we have to go back up and check the answer to make sure it's okay. And so let's just have a reminder here. I can have log base of anything, but I have certain kinds of problems that can go in this spot right here. This number can never be negative, and it can never be 0, because you can't take anything to a power and get a negative number or a 0. So I'm always going to check the problem when they start off as logs and make sure it's okay. 5 times 2 is 10. 10 minus 1 is 9. It's okay to have 9 in this spot. 2 plus 7 is 9. It's okay to have 9 in this spot. So we're all good there. So I think these will be easy problems for you, but let's talk about one where this side is a log and this side is not. So let's say log base 5 of 3x plus 1 equals 2. So this time the problem starts off as a logarithm. So in order to solve it, because this side is not log base 5, we're going to have to use the inverse operation. And the inverse of a logarithm is exponent. So I'm going to turn this log problem into an exponent problem. Since it's base 5, then this becomes base 5 on the other side. So I'm going to have 5 to the second power equals 3x plus 1. So 3x plus 1 equals 25. 3x equals 24. So x equals 8. And then anytime that the problem starts as a log, I have to go check. Is it okay to put an 8 here? 3 times 8 is 24. 24 plus 1 is 25. And 25 is an okay number to have there. Let's do one more like that. Log base 4 of x plus 3 equals 2. So since this side is not a log, I'm going to turn this into an exponent. So 4 is the base, 2 is the exponent, equals x plus 3. So x plus 3 equals 16. So x equals 13. And if I put 13 back in for x, if I put 13 back in for x, that's okay. The only number I cannot have here is a negative number. If that happens, then the solution is extraneous.